Hello students, in this video we will be studying the definition of region of convergence in Laplace transform. Mathematical expression of Laplace transform is given by this expression xs. Now this xs will be finite only if absolute value of this expression, that means this absolute value of this expression will be less than infinity. So then that means it should be absolutely integrable, then only you will get the finite value of xs. So for that we need to see on which condition this absolute finiteness of this integration is dependent. For that I have just solved this expression further. Here in this step I have just applied absolute mod value to the individual entities by using this property that mod AB is equal to mod A into mod B. After that I have placed the value of S is equal to sigma plus j omega here. Then so it becomes mod xt into mod e raised to minus sigma t minus j omega t dt less than infinity. Again here this is split into two quantities, that is mod e raised to minus sigma t, e raised to minus j omega t, as mod ab is equal to mod a into mod b. E raised to minus sigma t minus j omega t is we can split it into e raised to minus sigma t into e raised to minus j omega t. So we have got it as xt this expression we will get. So after that we know that mod of e raised to minus j omega t, that means mod of e raised to imaginary value is equal to 1, because e raised to minus mod e raised to minus j omega t is equal to square root of sine square omega t plus cos square omega t, and that is equal to 1. That's why in the next expression I have escaped the absolute value of e raised to minus j omega t. So we got only integration minus infinity to infinity mod xt into mod e raised to minus sigma t dt, and this should be less than infinity. So from where we have started with the definition of Laplace transform, that is xs is equal to minus infinity to infinity xt e raised to minus st dt. S is a complex frequency which is equal to sigma plus j omega. Then after that, for existence of this x, that means to get the finite value of x, this integration, absolute value of this integration should be less than infinity, or it should be absolutely integrable. That means if you take the absolute value of this integration, you should get that value less than infinity. So here in this expression we have applied absolute or mod value. After that we have split the mod value into two, that is mod xt into e raised to minus st. We have written it as mod xt into mod e raised to minus st. After that we have placed the value of s. After that we have escaped e raised to minus j omega t, because mod e raised to minus j omega t is equal to 1. So this expression shows us that this absolute value will be less than infinity, or finiteness of this integration depends on sigma value only. It depends on the sigma. The sigma is a real value of s, and I have taken out absolute value of e raised to minus sigma t also, because all the exponentials are positive. That's why I have written, instead of mod e raised to minus sigma t, I have written it as e raised to minus sigma t only. So from the above expression we conclude that finiteness of xs depends only on the values of sigma or real s. So that is the definition of your region of convergence, a region in which Laplace transform is finite or converges. It is the region in which Laplace transform is finite or converges, or it is the region of or range of values of sigma for which Laplace transform is finite or having the value less than infinity. So we have started it from mathematical expression. Then we have concluded that we have seen that the mathematical expression of Laplace transform contains integration from range minus infinity to infinity to now to have this integration value less than infinity, then only we will get access as finite. So we have solved this expression, and we have seen that it depends on the real values of S, and those real values of S are nothing but the region of convergence. Here the definition, some change you can also made in this definition is a region. Instead of a region, we can write it as a range of values of sigma in which Laplace transform is finite or converges. So this is the definition of Laplace transform. This is the definition of region of convergence in Laplace transform.